Welcome to Data Masterclass podcast, where data leaders share their unique stories. In this episode, we talked with Moritz Heimpel, who is the head of data and AI operations at Siemens, about the topic how Siemens scaled data and AI innovation. Let's welcome your host, Alex Borek.
Hello, data leaders. It's great to have you back at our Data Masterclass podcast. And we're going to discuss today about industrial data and AI in the context of Siemens, one of the leading manufacturing automation companies in the world. And I mean, it's a conglomerate. You can tell us, Moritz, in a second what you guys do. I want to give a warm welcome to Moritz, who's the head of data and AI operations at Siemens AG. Welcome to the podcast, Moritz.
Hi, Alex. Thanks for having me.
So, Moritz, this sounds like a very exciting role, head of data and AI operations. What does it actually mean?
Well, it means what it actually says. So I'm part of a bigger organization within Siemens that focuses on data and AI. This means we're both focusing on all of the platforms that we need to run analytics and run AI, but it also means we're using those platforms to implement data products, use cases, build AI systems and applications. And we are not only doing this out of one team within Siemens. I mean, you can imagine that Siemens is, as you mentioned, a conglomerate. I think roughly 320,000 people work for Siemens. And I would like to say we are kind of the center of gravity. That is the central data and AI team, which, if you combine internals and externals, would make up for around 600 data experts.
Ooh, that's a big team.
But of course, we are not doing that on our own, because in the businesses, in the regions, in the different functions all around the globe,
yes,
we have people that work with data on a day in and day out basis. And that's why the data community in Siemens, if you want, is significantly bigger than just the team that I'm working for. In my current role, I'm focusing predominantly on providing a self-service data and AI platform to Siemens so that we can support people in building out their own use cases and projects with all of the tools and technologies pre-secured and at their fingertips. And of course, I'm focusing in that role also on collaborating a lot with different data teams all around the globe to understand what they need and to help them building their use cases. That's my current role, and that's why it's called Data and AI Operations, because we are, of course, not only operating that stack, but we are constantly innovating and changing it as well.
And so who are the main kind of customers of your platform and of your enablement offerings? I mean, give us a glimpse into the Siemens world, because not everyone is aware of the many things you guys do.
Right. So maybe I need to add that the whole data and AI department that I'm working for is part of the corporate, if you want, meaning the main customers are our own people, the people that sit in sales, in finance, in procurement, in logistics, that sit in R&D, that sell products to the outside world, and they have any form of analytics, data / AI need that they want to satisfy. This means that we are working across all functions, and we are working across all divisions or businesses within Siemens, and we are also working, of course, globally, because Siemens has people sitting everywhere in the world. And I would say the main focus, although not the only focus, is really to support the company in getting smarter and taking better decisions based on data and AI. But that's not the only focus, because, of course, we have more and more also, say, data and AI related needs that are customer facing or that are incorporated into our software and hardware products that Siemens sells. And many of those requirements are also covered by the same ecosystem, by the same set of technologies, and by also the same set of people. In the end, you need data engineers, analytics engineers, data scientists. So I would say our main focus, as we are part of the IT, is really being the analytics and AI department for Siemens. So our customers are predominantly internal, but that's not exclusive. There's also a lot of use cases where people build out similar solutions, but for customer-facing applications.
You mentioned a number of functions. What are the main verticals or like business divisions you're serving?
So on a high level, Siemens is distributed in, I would say, 4 main areas. The area that most people can relate to quite easily because it's something that you can see and feel on a daily basis is Siemens Mobility, the division that builds the trains, the ICEs, and whatnot that all of us know. As a second division, which is called Smart Infrastructure. In a nutshell, you could say any commercial building that you see is equipped with a lot of different technologies to do air conditioning, heating, firefighting, and things like that. And Siemens has a full-fledged portfolio on how you can equip those buildings and also create connected buildings if you want. The third portfolio we call is more towards factory automation. It's really factories and the shop floor. You can actually build any kind of factory purely on Siemens hardware, I would say. And then our last set of portfolios is the software business. So we do have a big division that focuses predominantly on industrial software. This means like simulation software, PLM software, CAD, a CAD/CAM solution, things like that. And those are the main 4 pillars that Siemens is built around. And of course, in all of those pillars, you have then all of the functions that I've earlier mentioned. You need to sell something. You have sales functions in all of those areas. You have procurement, you have logistics, and so on. So we are working for all of those businesses and, of course, of all of those functions, which, I mean, for me, this is normal because I started my career 15 years ago within Siemens, but I assume for many data people, this is a little bit strange because it's so diverse and heterogeneous. The number of systems, the way Siemens does business. How you do sales is completely different if you sell a train in India or software in the US, as you can imagine. So it's a very diverse and heterogeneous world, which also requires a very flexible and very distributed setup to accompany the data and AI needs.
And I guess, I mean, you mentioned you have roughly 600 people, including, I guess, some externals as well.
Yes.
And so how do you organize such a big team, in such a very diverse environment?
Good question, and a never fully solved question. I earlier mentioned kind of that we, looking only at our team, the data analytics and AI team, which I'm a part of, is distributed, I would say, in 4 main pillars in the beginning. So one team that is focusing on all the platforms that we need to execute all of those use cases. This is what I'm responsible for at the moment. Mm-hmm. Then there's a second set of teams that we call domain teams that use the platform to build out data products and use cases for the different domains.
Mm-hmm. And they are organized by domain, is that
domain,
right?
Yes,
Mm-hmm.
because in order to interact with the business on eye level and to understand their needs and to also understand how you can turn a business problem into a data problem and then build a solution for it, you need a lot of not only technical know-how, you also need a lot of domain know-how.
Right.
That's why we have organized our data teams by domains. And a domain for us is something like sales or finance, not a division or business or a region. So really functional domains, if you want.
Right.
Because there we see the biggest overlap across also the different businesses. If you want to do sales, yes, it's different. To go back to my earlier example, if you sell a train in India or a software in the US, but when it comes to KPIs, source systems, business logic that you need, it's still very similar, even if you look at the data from completely different angles.
Yeah, so the functional kind of similarities are much bigger basically than comparable. Like you can have 2 different divisions, but if you're still in a marketing function, you would do similar things basically.
Precisely. That's the underlying idea. And when you look at it from a data perspective, the domain know-how is more like organizable around those functions than it is around the businesses or the regions. From a data perspective, whether you are in Italy or in France makes no difference.
Yes.
For us, at least, there's no domain know-how from a data perspective that distinguishes between the regions, apart from very niche things that are very special to a certain country for us. Then the third pillar, going back to my story, is our AI team, which in itself is organized by domains again, for the same reason, but they are separated or organizationally for two reasons, I would say. Scientists love to work with other scientists, hence you can learn and exchange a lot.
Yeah.
And it's easier to build career paths as well for data scientists if they're not distributed in smaller or bigger other data teams.
And I guess the nature of use cases in that kind of second pillar and third pillar is very different. Is that right? Because in the third, it's really, in the AI one, it's really about modeling, complex modeling in the industrial context.
That's true. So, of course, you use the same tools and you're trying to solve similar problems no matter in what domain you operate as a data scientist. So there's definitely some good reasons why we organize our AI teams as one team, even though internally, again, it's organized by domains because, again, being a good data scientist without understanding what sales needs or what finance needs or what procurement needs or what the factories need typically falls short, and you have a hard time then really implementing use cases that are really operationally used. So the same thinking of domain know-how applies also here, I think, but in a slightly different flavor. And then the fourth pillar that we are operating is a slightly different area, I would say, is we are running also the global master data systems for Siemens. So, for instance, all of the business partners that we interact with, be it customers or vendors or other partners, this is a central system that Siemens uses, and then the data is distributed to all of the other systems that require that information. Same holds true for our materials and our products and things like that. They are running in our organization as well. You could argue they are not really part of an analytics and AI function, which is true.
Well,
I think our official title would be data management, analytics, and AI, and then it fits in again.
Yeah, I think it does belong to a data function. So I think it's a healthy place to be. And because if you just do use cases, you often miss out on these, master data functionalities that are needed for all these use cases.
That's true. And that was one of the trains of thoughts, that these master data systems and the data products on top serve and accommodate the needs of all domain teams.
Right.
And therefore, it fits quite well together in a day-to-day practice. If you have both the master data teams and the analytics teams in one organization, discussions can be done very quickly. Problem solving works quite fast, and it gets easier compared to really distributing those two organizations in order to interact on a day-to-day basis.
So tell me, how do the different verticals and the functions come up with new use cases? And is that, by the way, is that still something that happens frequently? Or is it rather that you build out, what you already started to build out, and roll out?
Answering your second question first, the demand or the hunger, if you want, for new analytics, at least currently, is something that is really constantly increasing.
Okay.
So within IT, I would say we're probably the fastest growing, or maybe the only growing function. There are several reasons to this. Now, of course, Siemens wants to become more data and AI driven and has identified that this is a competitive edge if we can take better and faster decisions, and if we incorporate fact-based and data and AI-based decision making in all of our processes and our day-to-day lives. So also executives are incentivized accordingly to invest into that area.
That's interesting.
You could also argue not doing that might rather be a competitive disadvantage, because I assume many other companies of similar size do similar things.
And it sounds like it's not only competitive disadvantage to the business, but it is also a competitive career disadvantage for executives if you don't engage in data and AI these days.
I think so, yes. So it's something I would, because I'm not in such a function, so I can more use anecdotal evidence or things that I observe. But I do believe that if you want to make a career in any given function that we earlier named, at a certain level, it's probably not good enough anymore just to be a good expert in the field. You also need to show that you are able to digitalize organizations and that you are able to change the way people work. And this typically also means that they focus more on using data and AI to either automate certain things they do on a day-to-day basis or to base their decision-making upon. And that's why I would agree with you. It's probably not written down somewhere as a law or so, but it definitely helps in being perceived as someone who is innovative. When you invest into such areas also out of a non-data function.
And so how do you guys come up with these use cases? Do people proactively think, we could do this with data and AI?
If I had a more straightforward answer, I would give it. But I think when it comes to how the ideation happens, this is super diverse, I think.
Right.
So
do you have a team that helps in ideation?
Right. So we have what we call an enablement team, which does not really have operational duties, but rather focuses on really accompanying people out there that have a business problem of whatever sort, which can be solved through data and AI through this whole journey of, hey, I have a certain problem or I have a certain idea. It does not necessarily be a problem. It could also be a new market opportunity or a new product that you think of, where I believe that's something I can solve through the data that we already have and the technologies that are available. But let's say you are a logistics expert and your main job is making sure that the trains and the buses with all of the materials that Siemens ships are in time and deliver the right things to the right customers, then typically, and exceptions exist, but typically you don't have in-depth data know-how. You need a lot of help from coming up with a certain idea. I think that can be done better than we do it right now, to actually turn this into a, let's say, user story or a set of user stories that you can actually ask a team to build. And that's why I said it's very heterogeneous. We sometimes accompany stakeholders really from the first idea until the implementations. And sometimes people do all of the ideation and concepts on their own and only approach us with, hey, what is the right architecture to build this and who are the right people that we could utilize? And more we also see that people in the businesses, or let's say bigger organizations in the business, build out their own data teams. Let's say a data science team in the finance organization, for example. And those people typically can do this on their own. They might need architectural advice here and there. They might need support on, say, more technically challenging things or performance tuning measures somewhere.
I guess data as well.
Or data integration and stuff like that, exactly. Or data access in some cases. But as soon as like these fundamentals are there, then the rest they can do on their own. So there we are not at all involved in the ideation and not at all involved in the implementation. We're more like only providing some
support, high-level support
and help to help themselves. So as we sometimes formulate it, we add then the missing pieces to make the other teams shine, because we are fine if those things are just being executed and implemented without us. Because I think that's the only way how you can also step-by-step democratize data access and the day-to-day of working with data.
And how, to which degree can you scale use cases? So you have figured out, hey, this works in marketing or for factories, and let's bring it to more factories. Yeah. Is that something that is wishful thinking, or is that something that is actually happening in reality?
It's interesting that you say factories, because I think that's the hardest place to actually scale use cases.
Because it's so heterogeneous? Is that?
Right. Yeah. And many use cases start with overcoming a connectivity problem. If you want to have machine data, for instance, and that's not something you can scale. Literally, a person needs to go on the shop floor and plug an edge device into a certain machine and customize it accordingly so that the data flows and so on. So there's some
and interpreting the data, because every machine
the time series data that you get is not like straightforward. There's no ontology that you can simply use and build upon. But I would say in general, it depends a little bit on the domain, I guess. So things that are, say, regulated, like finance, it's very easy to scale use cases across businesses, across countries. In other areas, especially, for instance, in the operations domain, as we call it, it's significantly harder. So we have transitioned a while ago from a approach that was oftentimes too much focusing on trying to consolidate requirements and needs in a use case to more like streamlining the way how these use cases are built. Because I think the technologies that you need underneath to build out a use case in the shop floor or a use case in logistics, there you find a lot of commonalities in order to use the same set of technologies and tools to build a use case. You also would find within those technologies a lot of best practices and standards and maybe even templates that you can reuse, where the domain you're working in or the use case that you're trying to implement does not really matter. These standards remain the same. And this is, I think, where we try to scale. It's not based on use cases. This sometimes works, but not very often. But rather scale the kind of what technologies we use to execute those uses and then how we build them and how we operate them later. So there's a lot of commonalities and good practices where you can leverage and benefit from economies of scale. I mean, let's take the other extreme. Imagine for every use case, the same team that executes a certain set of uses implements the full infrastructure, security needs and stuff like that on their own. I mean, that's very obvious that that's not a smart idea. And that already tells you that these things can scale. And then you have certain layers on top that also scale that are no longer technology related. Data products, for instance, you can reuse a lot for very different use cases.
Which you guys do, yeah? So basically
we focus a lot on, since 2 years, not since forever, but since 2 years, we try to really actively distinguish use cases from the underlying data needs and data products, exactly. We're still learning, but we also see that it makes use case execution so much easier and faster if you have high quality, easy to consume data products at hand, which I think even emphasizes this argument of don't spend too much time on trying to consolidate and harmonize requirements into one use case. Just use the same products and build the things you need on top.
Right.
It's way faster, it's way leaner, and oftentimes it's also cheaper.
So basically what you have is a common platform. You have common data products that you use cross use cases.
Yes.
You have your master data that you use across use cases, and maybe some of your approaches that are quite similar. Like you know how to do things step by step when you do a use case. So there's kind of an excellence in building these things.
Yeah, it's a good summary. I would not. What you see in parallel is, yes, all of those good practices exist and they're getting more and more adopted. But it's not like this happens at the same speed in parallel everywhere. So you see a very few, that sometimes I'm doing that with a colleague. We are opening the code repositories of different projects on a Friday afternoon. You see a very, let's say, heterogeneous quality on how people build out their solutions. So I think one constant effort that we are investing into the community, let's say as a central IT team, is a lot of investments into knowledge sharing, best practice sharing, offering pair programming sessions, offering training, certifications in certain areas, because this does not happen automatically. So it's a lot of energy that you need to invest into such a very distributed and heterogeneous ecosystem in order to make sure that also the quality of data work using the common set of technologies is constantly increasing. So that's a journey. It's not something where you will ever be finished, I think.
Yeah, it's a long journey. So look, you have some of the bread and butter use cases, like in finance and marketing, that probably bring you a lot of the benefits. Right. Now, what is very, very exciting, obviously being a Siemens, is this whole industrial space. You call it maybe operations, factories, and so on. What kind of exciting use cases that you can talk about? Maybe because it's been talked about already publicly. What kind of exciting stuff have you seen in the last years, which would you say, hey, this is really cool and advanced and maybe surprised you even?
I can name a few, and I'm not exactly sure whether all of them are public, but I don't think they are necessarily an IP or a trade secret. One very famous example that we have internally is a project we call Gen X, which tries to create foundational models that are fed by the industrial know-how that Siemens has. So I earlier said that we build software, we build the factory automation, hardware, we build the smart buildings and the trains. So we have a lot of know-how on how to design hardware products. That's, in the end, what you will get is a CAD file. And we also have a lot of experience on how to produce them. So if you design, let's say, a train, you need to build that also. And this is called a CAM, so a computer-aided manufacturing program, where you translate the designed product, whatever it is, into something that you can actually build in a production line step by step. And this takes engineers a couple of months typically to first, of course, design the product. And then you have a different engineer who creates the manufacturing plan. And this is really complicated to do so and to do that in an efficient way. And for more complicated designs, this can take literally 6 to 8 months to turn the designed product into a to-be-produced product. And you still need to build the production lines and stuff like that. And we do have a lot of files of CAD and CAM pairs, so the designed product and the manufacturing plan. So you can use those pairs and train an AI model so that if you give to that AI model a new designed product, a CAD file, you have already 80% of the manufacturing plan automatically created.
This is cool.
And this is only possible because we have so many
files.
If you want industrial knowledge about that in-house, because it's these files, you cannot train a LLM on this because these information do not exist in the internet. It's intellectual property of a lot of different companies. And we also typically don't get this from our customers, even if maybe they use our software.
Right.
A famous example is Coca-Cola uses our hardware to fill the bottles. And if we had access to the data that those controllers produce, we could backwardly derive the recipe. So obviously,
we're
not very interested in giving us the data, although Siemens probably has no near-time future plans to go into the beverage business. Anyways, it's a trade secret, so we will not get access to it. But still, we do a lot of these things on our own and can train. We call them foundational models that are fed with the industrial know-how. And those models we can then use to, for instance, build agents and co-pilots into our software business, software portfolio. So, for instance, we offer simulation software, and if you do a lot of simulation on your own, you can train the model, and then you have a co-pilot inside of the simulation software that helps then engineers to simulate faster in a completely different domain or in a completely different company. And
amazing.
This is where, this all started when the Gen AI hype broke loose, so to say. So it's still quite new, and Siemens has now published the first products accordingly. We call them the industrial co-pilots, and we still learn here day in and day out, first of all, how to build those co-pilots, how to deploy them, what training data to use, and then, of course, how to integrate them into the existing software installed base, if you want, because a lot of different customers use our software, sometimes on-premise, sometimes SaaS, and then it makes the integration of such features quite challenging as well. So this is I think from the outside world where we can use a lot of the in-house industrial knowledge to improve our services to the outside. This is a quite cool example.
Very cool example indeed. It's an amazing example. And do you use basically open source LLM pre-trained LLMs for that, or do you train completely from scratch?
Not sure whether but we partially train our own models, and sometimes we reuse already existing LLMs and build rack systems and customizings around it. It depends a little bit.
It's a mixture,
but I would say we do both.
Yeah. Wow, this is really exciting. What else do you see, that is exciting, in terms of industrial usage of data?
I think we have a similar story to tell of our smart infrastructure business. So basically the selling proposition in a nutshell is if you equip your building with all of these smart devices that help you to do HVAC, to do heating, to do also electricity optimization, where the lights are on and where they are off and things like that, then you don't need to invest into like multiple facility managers that are constantly on site and things like that. And in order to do so, you not only would need the Siemens hardware installed in your building, you would need to also have this hardware connected so that you can build the data and AI solutions on top. And you have to start somewhere, right? It's hard for us to go to different customers and convince them to give us all their data, and then we build something on top. So what we do here as well is, Siemens also operates buildings, commercial buildings, that we connect our own buildings first,
yes,
turn the data of those buildings into reusable data products, and then we can build, let's say, the actual data and AI solutions that we then want to really sell as value-add features to the hardware that we anyway sell, already pre-trained, already like kind of fed with a lot of data of our own buildings. We call this Building X, that's the official name then of this offering, to really not only deliver the hardware, but also then, let's say, software solutions on top or data and AI solutions on top that can be used to optimize the electricity consumption, to reduce CO2 emissions, things like that, to contribute also to like certain sustainability targets that all companies in Europe at least have. And that's in the end, this is, once the connectivity is established, it becomes very normal, if you want, data and AI use case that you can run on the same technology that you run all of the internal challenges as well on.
And I guess in this case, it would be more traditional ML, or that you can run.
Yeah, you can start with basic analytics like monitoring systems that tell you where are the lights on and off in your building, where are people right now, so things like that. And then afterwards, you start automating certain straightforward optimization processes. So lights go out at a certain point in time, and when there's no people around, and then you have already your first small AI algorithm in place. But then you can also try to control heating and air conditioning in such a way that these things work automatically. You can also make this dependent on weather conditions. Now, then you would need to add additional data that you don't get out of the building per se, but that you get from somewhere else. Well, it makes a difference how you do cooling or heating if you know that it's 28 degrees or -6, and that's these are all data challenges that you can address via data and AI. I would say that's why it's a very interesting domain, because you can use the same technologies and the same techniques for enormously wide range of different use cases. And I think that's also what, at least today or nowadays, I would say makes living in the data and AI space very interesting.
Yeah, it sounds indeed very, very exciting. The opportunities that you have internally and how you apply that then also to help your customers, which is even more exciting, because you have such a big industrial client base around the world that can then leverage these innovations.
Yeah, I guess I need to add as a disclaimer that I would say still data and AI related, or our digital portfolio, I think that's the official name, is the fastest growing within Siemens.
Right.
But it still does not represent, let's say, the biggest portion. And I don't know where we are in 10 years, but still Siemens earns like the vast majority of their money by selling the train. Let's stay in this mobility example. And then you can sell data solutions on top for operating those trains in the field, to do predictive maintenance, to maybe do all kinds of tracking and monitoring solutions on top, which you again need, going back to the competitive advantage, to have an attractive offering to train operators. Yes. But I think the cool thing is here that you kind of combine the physical and the digital world in a way that
it is.
Both worlds work together in a complementary way. And I would still say that the data and AI part is, let's say, add-on to the things that we sell traditionally, where the meaning, so to say, of the data and part is constantly growing, but it's still not even close to on par when it comes to, let's say, measuring revenue. So it's still a field that has a lot of growth potential, but at the same time does not represent the vast majority of the things that Siemens is doing.
Let's spend, Moritz, maybe 1 or 2 minutes also on your platform. I mean, you built a large platform to fuel this all. Can you give us a glimpse into, what are the components of the platform and what kind of tech stacks you use as the main components? Because I guess a bunch of data leaders are listening, and would be excited to hear.
I'm always not sure whether this is a secret, but I think I can mention some components. So internally, we call this platform Siemens Data and AI Cloud, a very straightforward name that says nothing and everything at the same time. And what we mean by this is a best-of-breed architecture of all kinds of different components or technologies that we try to integrate and bundle together so that engineers or scientists can use those set of technologies to build all of the use cases that I've earlier described. And of course, this starts with a set of different integration tools, both for batch and event, both based on cloud serverless tooling as well as some really low-code iPaaS tools. It continues with data lake, where we just use hyperscaler capabilities, so nothing special. And then, of course, you need data warehousing capabilities. That's something where I think that's publicly known, work with Snowflake at the moment. We add a full-fledged AI, ML Ops or LLM Ops platform next to it, which to some extent either consumes the raw data of the lake or the curated data out of the warehouse. Or if in the unstructured case, it's slightly different, but that's why these tools fit together. Again, for the AI-related activities, we rely a lot on hyperscalers.
Oh, so it's mostly so on the AI offering, it's mostly the hyperscaler offering that you would take.
Yeah. We
makes sense.
We do use both predominantly Azure and AWS. Not so strong on Google, although we have some use cases there. And build out then the frameworks, the pipelines, the CI/CD mechanisms, the templates, also the automatic provisioning of the infrastructure to different use cases and project teams. This is something that we do then via Terraform in this case, but we rely on the underlying capabilities of the hyperscalers. Then we operate a stack of different BI tools if you want, or observability tools as well, or process mining tools that you need for data visualization, data storytelling. And we also have tools for citizen developers, that people that want to do something with data but are not really savvy to code. Tools like Alteryx or Lime come to mind. And then there's also tools like Neo4j Graph database that is tightly integrated into the Siemens Data and AI Cloud. And going back 3-4 years, we exchanged one or the other technology here and there, but the different components were to some extent already existing, but they were existing as individual services and islands, individual IT services, if you want. And what we have focused on in the last 2 to 3 years is really turning those individual islands and services into one offering that we call Siemens Data and AI Cloud. So we invested a lot into automating processes through a common marketplace, where you can say, I need a Snowflake project, I need a data integration, I need a BI tool, and I need a project in the AI platform. And this is all kind of tightly coupled together with a common pricing model, with a common, let's say, integration between those components. So we try to abstract away some of the complexities that otherwise the data teams would need to solve on their own in order to combine those different components to one full-fledged end-to-end value pipeline. And this is something that it's not yet solved, it's not yet perfect, but we're getting better every day. To make simply ultimately, that's then my job to make the implementation and execution of those use cases easier and faster. Because I earlier said that's the area where we believe we can scale the easiest. Not saying that you cannot scale on the other areas as well, but this is there we know that we can scale, and there we know that any automation we build helps 2,000-3,000 developers to be a little bit faster every day than they used to be the day before. And this helps us then, of course, also to ship products and use cases in a faster way.
Wonderful. So, last question, Moritz. What excites you most about this whole, industrial data and AI space? What do you think, will be the next years, that we're gonna see that could be very, very interesting?
There's so many, so many things. It's really hard to choose one that excites me the most. I think what I have been lately invested in a lot is, and it's maybe more of a personal perspective. Traditionally, I was focusing a lot on like the structured data world. And I think that is something where also the whole industry is in the meantime quite mature on how to tackle data that is stored in one way or the other in a structured format. The unstructured world, yes, through copilots and Gen AI use cases, we have now way better technologies in hand on how to work with unstructured data, but how to do this in a scaled and good and easy to operate manner. Also in combination with what role metadata plays here. It's way more important than before, but how to do this in a good way. This is something where I think the next 2 to 3 years, of course, also in combination with LLMs that are getting better and better over time, this is a super interesting area where I think figuring this out fast and becoming good in the area of really managing and extracting value out of unstructured data is something that excites me at the moment the most. Maybe I give you one number. I think we did some estimates, and I think more than 90% of the data that Siemens obtains is not stored in tables. It's really stored in files in unstructured formats, from emails to code and everything in between. And to leverage this treasure in a scaled and also cost-efficient way, and to really create value out of it, this is something that excites me the most, how to do that best and how to turn this into a similar maturity that, at least in my opinion, we have on the structured data side already.
Amazing. This was our Data Masterclass podcast episode with Moritz Heimpel. He's the head of data and AI operations at Siemens AG, and he shared a number of very exciting stories of how you can leverage data and AI at scale in such an wonderful industrial complex environment as with Siemens. Thank you so much for being with us, Moritz. It's been a pleasure.
Thanks for having me. It was a pleasure. See you soon.